Good morning class, welcome to Jatin's Academy. So today in this class we will learn about the numericals of chapter 2, that is work, energy and power. These numericals I have taken from the book of concise physics Selina. So here we will see all solved and unsolved numericals. So first we will see numerical based on work, energy, power, which is from A part. So now we have to see some formula based on this. Formula used in this part. First formula we have, that is W is equals to F into S. Here W is equals to F into S means force into displacement. Okay, work done is equals to force into displacement. Next we have W is equals to Fs cos theta. Here we use W is equals to Fs cos theta when there is an angle between force and displacement. For example, we have force in this direction and displacement occur at another direction. So angle between them is theta. So here we will use W is equals to Fs cos theta. Next we have F is equals to mg. When the work is done toward the gravity or against the gravity, then we will use force as mg. Okay, here mg star it is written. Why? Because always force is not mg. It is not always. Sometimes due to gravity we will take force as mg. Next we have power is equals to work done per unit time. So next we have power is equals to force into velocity. This formula is very important. Power we will use as force into velocity as direct formula. Next we have efficiency. Efficiency we have power output over power input, or you can also say work output over work input. Wherever it requires, we use this efficiency formula. Next we have mass is equals to density into volume. In some numericals, density is given, volume is given. We have to calculate mass, then we will use the formula mass is equals to density into volume. So now we have to start solved examples from this chapter. So let's get started. First question we have, a crane pulls up a car of mass 500 kg to a vertical height of 4 meter. Calculate the work done by a crane. So in this question, what are the given quantities? Given quantities we have, mass of a car is given as 500 kg, clear, and the height up to which the car is raised, that is 4 meter. We have to calculate work done. We know that work done is equals to force into displacement. So in this case, what is force? Force is actually a weight of a body. So weight of body in this case is m into g. Mass we have 500 kg, and gravity, if it is not given, then we have to take 9.8. If 10 is given, then we will take a 10 value. So from this we got 4900 Newton. Now work done we have force is 4900, and displacement in this case we have height up to which it is raised, that is 4 meter. Now multiply this, we will got 19600 joule. So this is the work done by a crane pulls up a car of mass 500 kg. Now you can also convert it into kilojoule. How? By dividing it 1000 and multiplying it with 1000. Okay, so this 1000 joule become kilojoule, and here we got 19.6. So total work done in this case we can say that 19.6 kilojoule. Clear? Next we have, a force of 10 Newton displaces a body by a distance of 2 meter at an angle of 60 degree to its own direction. Find the amount of work done. In this question we have a case in which body displaces 2 meter in this direction. Okay, this is a displacement, and force is acting from its own direction at an angle of 60 degree. So this is the direction of force. So in this case we have to calculate the work done. So first of all, given quantities, force we have 10 Newton and displacement we have 2 meter. Next we have angle between force and displacement, which is 60 degree. Now Fw is equals to Fs cos theta. Why cos theta? because this time angle is there between force and displacement. Now work done is equals to force value is 10 Newton, displacement 2 meter and cos 60 degree. So from the value chart cos 60 we have 1 by 2. Okay, cos 60 degree we have 1 by 2. This is 2 and this is 10. So from here work done we got it as 10 joule. So this is the question with answer when angle between them is 60 degree. Next we have a boy of mass 40 kg climbs up a flight of 30 steps each of 20 cm high in 2 minutes and a girl of mass 30 kg does the same in 1.5 minutes. Compare the work done and the power developed by them if g value is 10 meter per second square. Now carefully see a boy whose mass is we have mass of boy is given as 40 kg. Okay, climbs up a flight means he is walking on the stairs which is of 30 steps. So stair is having 30 steps and each step is 20 centimeter high. This step is 20 centimeter high. Now we have to calculate the total height. How we will calculate the total height? Just carefully see, each step is 20 centimeter and total we have 30 steps. So total height we got it as, how many steps we have? 30 and each step is of 20 centimeter. Now here we will got h as 600 centimeter, but in SI unit we have to convert this. So h is 600 by 100, so we got it as 6 meter. So total height of the stairs, so the total height gained by the boy is 6 meter. Okay, now next we have to see, this is the mass of a boy. Now how we will calculate the force? Because we have to calculate the work done. Work done formula we know that force into displacement. So force in this case we have mg, that is weight of a body, m into g. Mass we have 40 and g we have 10. So here we get 400 Newton. So force is basically, force 1 is basically related to boy, and for girl we have mass of a girl it as 30 kg and the force developed by the girl, which is weight of the girl, is m2 into g. So here we have force created by the girl, that is mass of a girl we have 30 and g value we have 10. So force is 300 Newton. Now we have to calculate the work done by boy and work done by girl. Work done by boy we have W1, which is force into displacement. Force in this case we have, in case of boy we have 400 Newton and displacement we have 6 meter. So work done by boy we have 2400 joule. Now same for a girl. Girl we have force into displacement. Force value we have, that is 300 Newton and displacement value we have 6, that is 1800 joule. Now we have to calculate the ratio. Compare, we have to compare the work done. Compare means ratio. So work done by a boy over work done by a girl we have to calculate. So here we will calculate W1 by W2. So W1 value we have 2400 joule and W2 value we have 1800. So from here we got on 6 table we got 4 by 3. So work done by a boy over work done by a girl, we have 4 by 3. Clear? Now we have to calculate the power, means we have to compare the power. So what is the formula of power? Power we have work done per unit time, means we need work done as well as time. Work done we have already calculated. For a boy work done 2400 joule and for a girl 1800. Now let's see the time. So for a boy, what is the value of time? Time we have 2 minutes. So time here we got it as 2 minutes. Now convert it into its SI unit, multiplying it with 60. So 120 seconds. For a girl, time value we have 1.5 minute. Convert it into second. So 1.5 into 60. We got 90 seconds. Now we have to calculate the power developed by a boy. Power developed by a boy we have work done by a boy over time taken by a boy. Work done 2400 and time we have 120. So from here we got power as 20 watt. SI unit of power is watt, and power created or power developed by a girl is work done by a girl over time taken by a girl. So work done in this case 1800 and time we have 90. So again we got it as 20 watt. So power of both cases are same. So now we have to compare, means we have to find the ratio. So ratio of power we have 20 over 20, which we got 1 by 1. So power ratio we have 1 ratio 1, and work done ratio we have already calculated as 4 ratio 3. So in this way we are able to calculate the answer. Now let's see one more way to do this numerical. So in this numerical we have to calculate the ratio, means compare means ratio. So work done by a boy over work done by a girl. Work done by a boy we have force into displacement and force into displacement. Displacement is same because they are raised by same height. Okay, so force we have m1 into g and m2 into g. Now G and G is again same, cancel out. Mass value we have first case boy 40, second case 30. So cut. So work done we got it as 4 by 3. So work done ratio we got it as 4 ratio 3 directly. But this method you will use only when you have to calculate the ratio. Next we have to calculate power. Power developed by boy to a power developed by girl is work done by a boy, time taken by a boy, over work done by a girl over time taken by a girl. So here this is multiply in this side and T2 denominator of denominator become numerator. So W1 into T2 over W2 into T1. Clear? Now W1 over W2 we have already calculated as 4 by 3. W1 over W2 4 ratio 3. Time, no need to convert it into SI unit. Why? Because when you will multiply 60 here, 60 here, again it is cancel out. So T2 value we have girl time 1.5 and here boy time 2. So now 4 by 3, this you got it as 15 by 10. Okay, and 2. Now cancel it out. We got it as here 2, here we have 5, and here we have again 5. So 5 and 5. So ultimately we got 1 by 1, which is 1 ratio 1. So power developed by a boy to power developed by a girl are same. So this is 1 ratio 1. So in this way you can also calculate the comparison only. Individual values you have to calculate from the previous formula only. Okay. Next we have a force of 15 Newton is required to pull up a body of mass 2 kg through a distance of 5 meter along an inclined plane, making an angle of 30 degree with the horizontal as shown. Diagram I will shown. So here you have to calculate the work done by force in pulling the body, force due to gravity, work done against the force due to gravity, and account the difference. So this question we will see carefully. See, so in this question, a 15 Newton force is required to pull up a body of mass 2 kg. So this body mass is 2 kg through a distance of 5 meter. This distance we have 5 meter along this inclined plane, which is making an angle 30 degree with the horizontal, which is shown in figure. So actually this block is moved in the upward direction by this force, by this 15 Newton force. Okay, and the mass of the block is given as 2 kg. Okay, that you can also convert it into Newton, but mass is given as 2 kg. Now we have to calculate. First question we have work done by force in pulling the body, means how much is the work done by a force to pull this block on this inclined plane. Now carefully see in this question what is the major mistake mostly student will done. Student will do work done it as Fs cos theta. So force we have 15, displacement we have 5 and cos 30. Okay, so they will calculate, and this answer is wrong. This is the wrong answer. Why? Carefully see. F as cos theta will only apply when there is angle between force and displacement, or if there is angle between force and displacement like this. So in this case only cos theta will apply, otherwise you can't apply the cos theta. Here in this case carefully see, force in this direction and displacement is also occur in this direction. Force and displacement direction is same. If force and displacement direction is same, then you can't apply the formula f as cos theta. In this case angle is 0, so simply we will use the formula w is equals to f into s. So force in this case we have 15 Newton, and displacement in the inclined plane, on the inclined plane we have 5 meter, so here we got 75 joule. So in this case work done we got 75 joule. Now why we have not applied cos theta, this concept must be clear. Okay, next we have force due to gravity. Force due to gravity, this force I am talking about, force due to gravity, that block, which is F is equals to m into g. Force we have, oh sorry, mass we have 2 kg, which is given in the question, and g value we have 9.8. So here we got m into g, this we got 19.6 Newton. So force due to gravity we got it as 19.6 Newton. Next we have to calculate work done against the force due to gravity. Work done against the force means what? This block is moving upward. Okay, this block here we have to see it is moving upward against the force of gravity. So now we have to use work done formula as F into S. Force in this case we will take this force m into g, which we have already calculated 19.6 Newton. Now we have to see the displacement. What is the displacement? Carefully see. In this direction we have to take the displacement. Basically in this question we have three displacement. One this displacement, one this displacement, and one more displacement we have, which is this displacement. If I mark it as A, B, C, now carefully tell me, when force is applied in this direction, work done we have force and displacement in the direction of force. So according to this force, in the direction of force displacement we have this BC. So ultimately we have to calculate this value of BC. Now how we will calculate force? We have 19.6. Displacement we have to calculate, which is BC, which is actually a height. Okay, this height we have to calculate, and if you will see, apply the trigonometric formulas. So here we have, this is theta angle, and in front of angle we have a perpendicular, and this is base, and 90 in front of we have a hypotenuse. Clear? Now perpendicular we have to calculate, and hypotenuse we have. Which formula we will use? Pandit Badri Prasad har har bole sona chandi tole. This is the mnemonics. Now what we will use? We need perpendicular, we have hypotenuse, so we use s. S means sine theta. So sine theta we got it as, here we will calculate sine theta. We have perpendicular, which is BC, over hypotenuse, which is AB. Sine theta, theta in this case we have 30 degree, and BC value we have to calculate height, and here we have hypotenuse as 5. Sine 30 value we have 1 by 2, so put the value as 1 by 2 here. So h we got it as 5 by 2 meter. Clear? 5 by 2 we got it as height. So now 19.6 into 5 by 2. Now when you will multiply this, you will got work done against the force of gravity. We got it as 49 joule. Clear? So this is the way in which you will calculate the work done against the force of gravity. So here you need a h. So you can also remember the formula that W is equals to mgh. You can remember this formula. This height represent the vertical height. Clear? Not a base, not an inclined height. We are getting it as a vertical height. Next we have account the difference in the answer in part 1 and part 3. Part 1 answer, let's calculate. Part 1 answer we got it as 75 joule and part 2 we got it as 49. So part 1 we have 75 joule and next we have 49. So this we got it as 26 joule. So why there is a difference? Carefully see. This is the total work done. 75 is the total work done in moving. In this case, block is moving in this direction also, in this direction also. Means when the block is moving on the inclined plane, height is also get raised, as well as it is also moving on a rough inclined plane. So this 26 joule is nothing but it is the force of, this is the force of, we have friction. Clear? This is a force of friction. Friction is applied by the rough inclined plane on the block. So to overcoming the friction, some force is required, and overcoming this friction, work done is also required. So this work done is basically to overcome the friction. Clear this part? Next question we have, calculate the power of an engine required to lift 10 raised power 5 kg of coal per hour from a mine 360 meter deep. Take G value as 10 meter per second square. So here we have to calculate the power. In this case, given quantities we have, mass of a coal we have 10 raised power 5 kg. Next we have per hour, means time is given it as 1 hour. 1 hour basically we have 3600 seconds. Next we have 360 meter as a height or depth, you can say. Now we have to calculate the power. Power we have work done per unit time. Work done we have force into displacement over time. But here force is not given. So if force is not given, mass and G is given. So force value we have M into G. So here you can write F is equals to M into G. And displacement in this case we have a height. Over time we have T. Now put the values. Mass 10 raised to power 5. G value we have 10. H value we have 360 over 3600. Now from here this 0 is cancelled with this, 360 purely cancel out. No, so power we have 10 raised to power 5 watt. So now you can also convert it into kilowatt. How? Just multiply like this, 100 into 10 raised to power 3. 10 raised to power 3 is basically a kilowatt. So 10 raised to power 3 watt is a kilowatt. So answer we got it as 100 kilowatt. So power value we got it as, in this case we have 100 kilowatt. Next question we have, an electric motor of power 100 watt is used to drive the stirrer in a water bath. If 50% of the energy supplied to the motor is spent in stirring the water, calculate the work done on water in 1 minute. So let's first write the given quantities. Given quantities we have power. Electric motor of power means this is the power of electric motor which is required to run the motor. Okay, this is a power input, you can say that. Next we have used to drive the stirrer of bath, and efficiency we have 50%, which is 0.5. Energy supplied to a motor in spent in stirring the water. Calculate the work done on water. Work done on water, basically we have to calculate work output, how much work is done by the motor on the water. So work output we have to calculate basically, okay, in 1 minute. Time it is given as 1 minute, which is equal to 60 second in SI unit. Now we have to calculate the efficiency formula. We have power output over power input. Okay, this is the SI efficiency formula. Efficiency we have 50%. Power output we have, basically we have to calculate. Power input we have 100 watt. So power output in this case we got it as 100 into 0.5, which is 50 watt. Now we have to calculate what is What we have to calculate now? Work output. Work output we have power output into time. Directly I am using, because we know that power is equals to work done per unit time. So work done we got it as power into time. Power output we have 50 watt and time we have 60 seconds. So 50 into 60 we got 3000 joule. Okay, 3000 joule, or you can also write it as 3000 joule, you can write it as kilojoule. So 3 kilojoule work output or work done in 1 minute, or 3000 joule, both are correct answer. Clear? Next we have a man exert a force of 200 Newton in pulling a cart at a constant speed of 16 meter per second. Calculate the power spent by man. So here it is given that force is given as 200 Newton and constant speed means velocity is given as 16 meter per second. You have to calculate power. Power we have to calculate. Direct formula we will use. Power formula we have force into velocity. This we have already derived in the theory part also. So force we have 200 and velocity we have 16 meter per second. So here we got it as 3200 watt. So power in this case we have 3200 watt. Formula directly we have used force into velocity. Next question we have, work done by a heart is 1 joule per beat. Calculate the power of the heart if it is beat 72 times in a minute. So in this case, in one beat the work done by a heart is 1 joule, and we have to calculate the power in 1 minute. In 1 minute it beats 72 times. So in 72 beats we have how much work done? That is 72 into 1 joule. So here we got 72 joule. Clear? 72 joule we have a work done. Now time is given as 1 minute. In 1 minute how many seconds are there? 60 seconds are there. So power formula we have work done per unit time. Work done in this case we have 72 joule and time we have 60 seconds. Now cancel it out. We will got it as 1.2 watt. So power developed by a heart in 1 minute, which beats 72 time, is 1.2 watt. Clear? Next we have express 5 kilowatt hour into joule. So here you can directly convert or you can convert by step. So here we have 5 kilowatt. You can write it as 5 into 1 kilowatt hour. In 1 kilowatt hour we directly have 3.6 into 10 raised to power 6 joule. Directly this value you can remember. So 5 into 3.6 into 10 raised to power 6 joule. So 5 into 3.6 we got it as 180 or 18 into 10 raised to power 6 joule. So here you can stop the answer by writing it as 18 megajoule, or you can convert it into physics unit by divide it by 10 and multiply it with 10. So here we got 1.8, and here you can write base same power at 10 raised to power 7 joule. So this is the expression, means 5 kilowatt hour is converted into joule. Next we have the energy of electron is given as 4 into 10 raised to power minus 19 joule. We have to convert it into electron volt. How we will convert? First of all we should know what is the relationship between electron volt and joule. So 1 electron volt we have 1.6 into 10 raised to power minus 19 joule, which is also the charge on the electron. So it means that in 1 joule we have 1 over 1.6 into 10 raised to power minus 19 electron volt. So now what we will do here, we will write 4.0 into 10 raised to power 19 into 1 joule. So we have separate this joule. 1 joule value we have in electron volt put directly. So 1 joule we have 1 over 1.6 into 10 raised to power minus 19 electron volt. This 1 joule I have replaced with this value. So this minus 19 cancel out. 4 over 1.6, which is 4 over 16, and this 10 is got here. So here we got it as 4. 10 by 4 means 2.5. So at the last we got it as 2.5 electron volt. It means 4 into 10 raised to the power minus 19 joule is basically 2.5 electron volt. So in this way you can do these numericals. Clear? Next we have numerical based on work, energy and power. We have to do unsolved numerical. So first numerical we have a body when acted by a force of 10 kgf get displaced by 0.5 meter. Calculate the work done by a force when the displacement. So here we have three conditions. First we have in the direction of force, second at an angle of 60° with the force, and third we have normal to the force. So G value is given as 10. Now work done we have to calculate. So we need force and displacement. Force it is given as 10 kgf. So 10 kgf first we have to calculate into Newton. So 10 kgf converted into Newton. So multiply with G 10. So here we got it as 100 Newton. So force we got it as 100 Newton and displacement we got it as 0.5 meter. Now first case we have when the force and displacement both in the same direction. So when force and displacement both in the same direction, so work done we got it as force into displacement. Force value we have 100 and displacement value we have 0.5. So work done we got it as 50 joule. Clear? Second part we have when force and when displacement is at an angle of 60° with force. When force in this direction and displacement occur at 60°. So here formula we will use Fs cos theta. Force value we have 100, displacement 0.5, and theta in this case we have cos 60, and cos 60 we know the value of cos 60 is 1 by 2. So here we got 25 joule. Okay, so work done in this case we got 25 joule. Third case we have when displacement is normal to the force. This is displacement, this is force, this is displacement, angle is 90° normal. So work done we have Fs cos theta. Force 100, displacement 0.5, and cos theta. Theta in this case we have 90, and cos 90 value we have 0. So 100 into 0.5 into 0. So work done in this case we have 0 joule. So three cases basically we have. From all these cases concept is clear that how to use the work done formula for different angles. Next question we have a boy of mass 40 kg climbs up the stairs and reaches the roof at a height of 8 meter in 5 seconds. We have to calculate the force of gravity acting on the boy. Next we have to calculate work done by him against the force of gravity. Why they are saying against the force of gravity? Because the boy is moving upward and force of gravity is acting downward. Next we have power spent by a boy. So first of all write the given quantities. Given quantities we have mass of a boy we have 40 kg and climbs up a stair and reaches a height which is also a displacement is 8 meter, and time we have 5 seconds. We have to calculate force of gravity. Force of gravity we have m into g. Mass value we have 40 kg and g value it is given as 10 meter per second square. So here we got 400 Newton as a force of gravity acting on a boy. Next we have work done by him against the force of gravity. Work done we have force into displacement. Force we have 400 Newton and displacement we have 8 meter. So multiplying we got 3200 joule as a work done. So work done against the force of gravity we have 3200 joule. Next we have power spent by boy. Power we have work done per unit time. Work done formula we have already calculated, work done 3200, and time we have how much? 5 seconds. So 3200 by 5 we got 640 watt. So power spent by a boy, we have 640 watt. Clear? Next question we have, a man spends 6.4 kilojoule of energy in displacing a body by 64 meter in the direction in which he applies a force in 2.5 seconds. Calculate the force applied and the power spent in horsepower, means we have to calculate. First write the given quantities. Given quantities we have, a man spent 6.4 kilojoule of energy. Energy means work done. Okay, so work done in this case we have 6.4 kilojoule. Now convert it into joule, multiply by 1000. So we got 6400 joule as a work done, and displacement is given as 64 meter, and time it is given as 2.5 second. First we have to calculate force applied. Force we have work done is equals to force into displacement. So force we got it as work done by displacement. Work done we have 6400 and displacement we have it's 64 meter. So cancel it out. So we got 100 Newton. Okay, force we got it as 100 Newton. Now we have to calculate power. Power is work done per unit time. Work done 6400, time we have 2.5 second. So here we got 2560 watt. Now we have to convert this 2560 watt into a horsepower. 1 horsepower we have 746 watt. So how to convert this? Just divide your answer with 746. So we got 3.43 horsepower. Okay. So in this way you are able to convert your power which is in watt into a horsepower. Next question we have, a weightlifter lift a load of 200 kgf to a height of 2.5 meter in 5 seconds. Calculate the work done, the power developed by him, take G value as 10 Newton per kg. So here they are given load. Load means force is given 200 kgf. How to convert kgf into Newton? Just by multiplying it with G. G value is 10. So 2000 Newton we got as a force. Now height is given as 2.5 meter and time is given as 5 seconds. Okay. Now we have to calculate work done. What is work done? Work done we have force into displacement. Force value we have 2000 Newton and displacement we have 2.5 meter. Okay. So you can also write 2.5 as 5 by 2. So here you got 5000 joule. You can also write it like this, 5 into 1000 joule, which is a kilojoule. So 5 kilojoule is a work done. Next we have calculate the power. Power is equals to work done per unit time. Power we have, work done we have 5000. Power, for power time we have 5 seconds. So here we got 1000 watt. 1000 watt you can also write 1 kilowatt. So this is the required answer. Next question we have, a machine raises a load of 750 Newton through a height of 16 meter in 5 seconds. We have to calculate the energy spent. Energy means work done. Okay, energy spent means we have to calculate work done, and power of machine if it is efficiency is 100%. A machine raises a load means force value is given as 750 Newton and height or displacement is given as 16 meter and time is given as 5 seconds. So simply work done we have to calculate as force into displacement. So force value 750 Newton and displacement we have 16 meter. So multiply this, we got 12,000 joule or 12 kilojoule. Directly I can write like this, 1000 I convert it into kilojoule. Next we have power of machine. Power we have work done per unit time. Work done we have 12,000 over time we have 5 seconds. So divide this, you got 2400 watt. Here you can leave the answer. You can also divide it by 1000. Wait. Divide it by 1000 and multiply it by 1000. Clear? So you will get here cancel out 2.4 kilowatt. So in this way you can convert your answer into kilowatt also. Next we have an electric heater of power 3 kilowatt. Power is given as 3 kilowatt, okay, and use for time is given as 10 hour. We have to how much energy is consumed. Energy means work done, okay, energy means work done. Express your answer in kilowatt hour and in joule. So power is equals to work done per unit time. So work done is equals to power into time. Work done is also called energy. So we can say that energy is equals to power into time. So energy is equals to power value we have 3 kilowatt, okay, and time we have 10 hour. Why I am writing like this? Because this answer I got 30 kilowatt hour, which is the first answer. So first answer we need in kilowatt hour. So kilowatt hour we have 30 kilowatt hour. This is my first answer. Second, I have to convert this answer into joule. So converting this 30 kilowatt hour, I am writing 30 into 1 kilowatt hour. And in 1 kilowatt hour, how many joules are there? Relationship we have directly that 3.6 into 10 raised to power 6 joule. Okay, so multiply this 30 into 3.6 into 10 raised to power 6 joule. So when you multiply this, you will get it as 108 into 10 raised to power 6 joule. Now in order to convert it into physics unit means we have to put a decimal here, means after one digit we have to put a decimal. So divide it by 100, multiply it with 100. So we got 1.08 into 10 raised to power 8 joule. So this is our required answer, which is in joule. Clear? Next we have a water pump raises 50 liter of water through a height of 25 meter in 5 seconds. We have to calculate the power of the pump required, and gravity and density of water is given. Why density of water is given? Because mass of water is not given. So firstly we have to calculate the mass. What are the given quantities? Carefully see. Volume of water we have 50 liter. So in order to convert 50 liter you can write capital 50 liter into a SI unit. So just divide it by 1000. So you will get answer in meter cube. So we got 5 by 100 meter cube as a volume. Okay, now we have to calculate mass. We know the formula, density is equals to mass per unit volume. Here we have given as height and here we have time. So mass density is equals to mass per unit volume. So mass we have density into volume. Density value we have 1000. Okay, volume in SI unit we have 5 by 100. So from here we got 50 kg. So 50 kg we got the mass of the water. Now we have to calculate the power. Power is equals to work done per unit time. Work done is force into displacement over time. Force in this case force due to gravity, m into g into displacement over time. Mass value 50 kg. Gravity we have how much? 10. Displacement means height 25 and time we have 5. Okay, so from here we got 2500 watt as a power. Clear? So this is the power required to raise a water of 50 liter through a height of 25 meter in 5 seconds. Next question we have, a pump is used to lift 500 kg of water from a depth of 80 meter in 10 seconds. We have to calculate the work done by the pump, the power at which the pump works, and the power rating of a pump if its efficiency is 40%. G value is given as 10 meter per second square and density is given as 1000 kilogram per meter cube. So first part we have to calculate the work done. We know that work done is equals to force into displacement, and force in this case we have mass into gravity and displacement is S or H. So mass value we have 500, G value it is given as 10 and height is 80 meter. So here we got it as 40 1, 2, 3 and 4 zeros. Okay. Now we have to convert, this is the joule. Now we have to convert it into kilojoule. Just divide it by 1000 and it become kilojoule. So here it got 400 kilojoule. So work done, we got it as 400 kilojoule, or you can also write 1, 2, 3, 4, 5, that is 4 into 10 raised to power 5 joule. In any way you can write the answer. Next we have the power at which pump work. Power we have work done per unit time. Okay, work done we have 4 into 10 raised to power 5 and time we have 10 seconds. So this 110 is cut with this, so it become 4 into 10 raised to power 4 watt. You can also write like this, 40 into 10 raised to power 3 watt. 110 I have given to this 4. So 40 kilowatt is the power. So this is basically a power output. Power output which is given by the pump to raise the water. Now next question we have, find the power rating of pump. Power rating means we have to calculate power input. Okay, so efficiency we have power output over power input. Clear? Now efficiency 40% means 0.4. Power output is given as 40 kilowatt. Now we have calculated power output in the previous case 40 kilowatt. So put the value 40 kilowatt, and power input we have to calculate, which is also called power rating. Okay. Now what we will do, just divide this power input as 40 by 0.4, which is 40 into 10 by 4. So it become 100. The question, in the question we have this in kilowatt. So here we got answer in kilowatt. So power input or power rating we got it as 100 kilowatt. Clear? Next question we have, an ox can apply a maximum force of 1000 Newton. It is taking part in cart race and is able to pull a cart at a constant speed while making its best effort. Calculate the power. So given quantities we have force and next we have velocity, which is 30 meter per second. Now we have to calculate the power developed. So power we have force into velocity. Force we have, this is the direct formula I am using. Force we have 1000 and velocity we have 30. So here we got 130 into 10 raised to power 3 watt, which is called 30 kilowatt. So this is the answer, which the power developed by a ox. Next we have the power of a motor is 40 kilowatt, and at what speed the motor speed we have to find to raise the load of 20,000 Newton. So in this case power is given as 40 kilowatt, which I can write it as 40 into 1000 watt. Okay. Next we have to calculate, 1 minute. Okay. Now we have to calculate the velocity, and it is given that speed and velocity we have to calculate same thing. Here we have to calculate load in this case force we have 20,000 Newton. Now we have formula, power is equals to force into velocity. So velocity or speed we have power over force. Power we have 40,000 and force we have 20,000. So cancel it out. We got velocity as 2 meter per second. So velocity in this case we got 2 meter per second. Next we have Rajan exert a force of 150 Newton in pulling a cart at constant speed. Calculate the power. Again formula is same. Power is equals to force into velocity. Force 150 Newton and velocity or speed we have 10. So we got 1500 watt as a power. Next we have a boy weight 350 Newton climbs up 30 steps of each 20 centimeter high in 1 minute. We have to calculate work done and power. Now carefully see, for us raising a steps, So basically we have 30 steps and one step is 20 centimeter high. 20 centimeter high. So total step we have 30. So what is the total height? Total height we have how many steps? 30. One step is of 20 centimeters. So 600 centimeter. Converted into meter divided by 100, we got 6 meter as a height. Now force is given as 350 Newton and we have a time as 1 minute, which is 60 seconds. Clear? Now we have to calculate work done. Work done we have force into displacement. Force value we have 350 and displacement we have how much? Height. Height we have 6 meter. So 350 into 6 we got 2100 joule as a work done. Now we have to calculate the power. Power is equals to work done per unit time. Work done we have 2100 joule and time we have 60 seconds. So here we got as a 35 watt as a power. Clear? Next we have it takes 20 seconds for a person A of mass 50 kg to climb up a stair while another person B of same mass does in 15 seconds. Compare the work done and power developed by person A and person B. Now we have to compare the work done. Carefully see. Work done directly we will compare work done by 1, work done by 2. That is work done by A, or you can also write work done by B. Directly we will calculate. So this is force by A, displacement by A. This is force by B, displacement by B. Here force is not given, mass is given. So mass of A into gravity into displacement of A over mass of B into gravity into displacement of B. They are saying that for a person A climbs up stair and while another person same mass, here mass is same, means MA is equals to MB, and they are raising up a same stairs, they are going to same stairs, so displacement or height is also same. Okay, so now mass is same, cancel out, G is same, cancel out, displacement is same, cancel out. So work done we got it as 1:1. Clear? Now we have to calculate the power developed. Power, for that we need a time. So time for A 20 second, time for B 15 second. So power we have power of A over power of B, that is work done by A over time taken by A over work done by B, time taken by B. This time is multiply here and this time is multiply here. So work done A by work done B, time B over time A, time taken by A. So this work done ratio we have already calculated 1/1. Time B, time taken by B boy, that is 5, 15, and here time taken by A we have 20. So here we got it as 3/4. So power ratio we got it as 3:4. So in this way we can directly compare the work done and the power developed by the person A and B. Next question we have, a boy of weight 40 kg climbs up 15 steps each 15 centimeter high in 10 seconds and a girl of weight 20 kg does the same in 5 seconds. We have to compare the work done and power developed by them. Now carefully see, directly we will do this question. We have to compare the work done. So work done by boy over work done by girl, that is force developed by boy into displacement by boy to force developed by girl into displacement of girl. So in this case both are climbed the same stairs, so displacement by boy is equals to displacement by girl. Okay, so displacement covered by boy is equals to displacement covered by girl, so both are same. Now force we have mass into gravity, so mass of boy into G over mass of girl into G. So here we got G cancel out, mass of boy we have 40 and mass of girl we have 20. So simply we got here work done ratio as 2:1. Okay, 2/1, 2:1. Now we have to calculate the power. Power we have power developed by boy to power 12 by girl. Wait. So power formula we have work done per unit time and work done per unit time. So here this time is multiplied here and this time is multiplied here. So work done by boy over work done by girl into time of girl over time of boy. This work done ratio we have already calculated as 2 by 1, 2 ratio 1. Time taken by girl we have here 5 seconds and time taken by a boy we have 10 seconds. Okay, 5 second over 10 second, this got 2, 2 and 2 cancel out, 1 by 1, so 1 ratio 1. So power ratio we have 1 ratio 1 and the work done ratio we have 2 ratio 1. Clear? Next question we have, a man raises a box of mass 50 kg to a height of 2 meter in 20 seconds, while another man raises the same box to the same height in 50 seconds. We have to compare the work done and compare the power developed by them. Next we have to calculate the work done and power. Means in first case we have to compare, find ratio, and in next case we have to calculate the value. G value is given as 10. So first what we will do, a man raises a box. So we have to compare the work done. Comparison of work done means ratio. So force of A into displacement of A over force of another man and displacement of another man. In this case height is same, so displacement is same. Okay, so this displacement is same. Next they are saying that while another man raises the same box means force is also same. If boxes are same, then they are applying same force, so force is also same. So in this case both are same, so here we got answer as 1 by 1 means 1 ratio 1. Clear? Now we have to calculate the ratio of power. So power dwell by A to power dwell by B, which is work done by A, time taken by A, work done by B, time taken by B. So this is multiply here and this is multiply here. So work done by A over work done by B to time taken by B over time taken by A. So this is 1 ratio 1, 1 by 1. Time taken by B. B time we have how much? 50 seconds. And time taken by A we have 20 seconds. So here we got power ratio as 5 ratio 2. 5 by 2 means 5 ratio 2. Now we have to calculate the values of work done and power. So work done first we will calculate by A person, which is mass force into displacement. Force we have how much? Force we have 50 into G, M into G into displacement. So mass we have how much? 50, G value we have 10, displacement we have 2 meter. So here we got 1000 joule. Now carefully see, both are raising same mass to same height. It means that work done by B is also 1000 joule. You can also put the same values or directly you can write work done is 1000 joule. Power we have power dwell by A, work done by A over time taken by A. Work done by A is 1000 joule and time taken by them is 20 second. So here we got 50 watt as a power. So power dwelled by first person is 50 watt. Now we have to calculate the power dwelled by B person or B man. So work done by B over time taken by B. Work done by B we have same 1000 and time taken in this case is 50 seconds. So here we got 20 watt. So in this way power we have calculated 50 watt and 20 watt. Clear? Next question we have, a boy takes 3 minutes to lift a 20-liter water bucket from a 20-meter deep well, while his father does it in 2 minutes. Firstly, we have to compare the work done and then power developed by them. And next we have to calculate how much work is done, means we have to calculate the value. And density of water is given and G value is given. So firstly we have to compare the work done. So comparison of work done by boy to the work done by father. that is force applied by boy into displacement and force applied by father into displacement. So in this case they are actually taking the same bucket and from the same well. So in this case force is also same. Why force is same? Because they are taking same bucket from same depth. So force value is same. And what is the value of displacement? Depth is also same. It means displacement is also same. Okay. So this all values are equal. So we got work done as 1:1. From here we get conclusion that if someone is taking a same object up to same height, means applying same force and applying same displacement, then the work done is same irrespective of their time difference. But time difference will be considered in case of power. Now we have to calculate the ratio of power 12 by boy to power 12 by father, which is work done by boy time taken by boy to work done by father over time taken by father. So this multiply here and this multiply here. So work done by boy over work done by father into time taken by father over time taken by boy. So this ratio we have 1:1. Time taken by father. Time taken by father we have 20 minutes. You can also convert it into second, but that is cancel out. And time taken by boy, it's 3 minutes. So here ratio we got as 2:3. So power ratio changes with time, but because force is applied same and displacement is same, so that's why work done is same 1:1. Now we have to calculate the how much work does each done. Both boy and father doing same work, which is mgh. Work done is force into displacement. Force we have mg and displacement is h. Now let's calculate the value of mass. Here mass is not given. Volume and density is given. We know density is equals to mass per unit volume. So mass is equals to density into volume. So here we have to calculate mass. So density is given as 1000 and volume is given as 20 liter. So 20 liter is actually 20 by 1000 meter cube. Liter, how to convert it into SI unit? Meter cube divided by 1000. So 20 by 1000. Okay. So here we got it as mass, we got it as 20 kg. So mass we got 20 kg. Now put the value in work done. Mass we have 20 kg. G value it is given as 9.8 and height we got it as 20 meter. So here we got 3920 joule. So 3920 joule, 3920 joule, we got it as work done. You can also convert it into kilojoule. Just divide it by 1000. Okay, so you got the answer in kilojoule. So we got 3.92 kilojoule is our work done. Clear? So here boy and father doing the same work because bucket mass is same, height is same and g is same. So work done, they are performing the same. So that's why same work done in each case we have 3.92 kilojoule. Clear?